Let's now look at antiderivatives involving some trig functions. So what we notice here is our variable now are all in terms of theta. So it makes sense if you have thetas inside here, you're also going to have a theta out here with the d theta. So this has to match. The variables inside and outside are matching. This is telling us we're taking the antiderivative with respect to theta. Okay, so when we do that with the first one, theta right there, we're still going to use the inverse power rule just as we would do if there was an x there. So the power on here is a 1. Raise the power by 1, divide by the new power. You're going to get theta squared over 2. Now next, for secant squared, this is one where you have to recognize one of those special antiderivative formulas that we talked about in the beginning of this section. That's a secant squared k theta. So that formula is going to go into tangent squared, but we're going to put a 1 over k out in front of it. So we're going to do 1 over 7, because 7 is a k value. And this is going to be tangent is 7 theta. And then don't forget to put the plus c on your answer here. Again, all these that we're doing are going to have a plus c on it because we don't have any other information to know what that c value is. And then we're done. So we're done with the first one. Now we're ready for this one. Now the second one is going to be a little bit more involved because we're going to have to use some trig identities for this one. So starting out, there's nothing we can do to simplify that right now because there's two things in the bottom, and if we try and divide, we can't divide by that, and we can't cross cancel anything, not allowed to do that either. So the first thing we need to do is look for an identity to put in here, and the one I see here is 1 minus cosine squared. We know that 1 minus cosine squared is equal to sine squared, so I'm going to use that trig identity in this one. So cosine 4 theta over, and on the bottom we're going to put in sine squared 4 theta d theta. Now at this point you might get stuck wondering what to do next. What you have to do is you need to break up the sine squared into sine times sine, and then we're going to create two different things that we can use more identities on later. So that may not be quite as obvious, but that's what you have to do here. So what do I mean by that? What you're going to do is you're going to write this as 1 over sine of 4 theta and then times cosine 4 theta over sine 4 theta. Okay, we're basically just splitting it up. So this writing it as sine squared, we write that as sine times sine. And you need to have a 1 on top here. It's not going to be a cosine on top because if you had a cosine on top also, when you multiply it across, you'd get cosine squared. So we only need one cosine. We want to put it with just one of them only. The other one's going to have a 1. That way when you multiply across the top, across the bottom, you'll get exactly the same thing you started with. Now this, because we split it up this way, we did that purposely because that way we can use more identities to put in there. 1 over sine is going to be cosecant, so cosecant 4 theta, and cosine over sine is cotangent 4 theta. And so once we get it in this form, you should recognize that this is going to be one of our special antiderivative formulas that we've talked about earlier in this section. If you have cosecant cotangent, that's going to turn into a cosecant, and then also we got a 4 there. That's going to be our k value. So we're going to do, it's negative, formula has it as a negative, negative 1 over k, and then cosecant 4 theta, and of course we got the plus c. So this is just again recognizing the special formulas that we talked about earlier in this section. This problem doesn't look like there's trig involved, but actually we're going to be using our inverse trig antiderivatives in order to solve this one. The main thing is recognizing what kind of form that you have here. So if I change it into 1 plus 2 squared x squared, the 4 can be written as a 2 squared there, then this is a format that turns into an inverse tangent from our formulas that we talked about before. The k value is the one that's being squared here, so the k is going to be a 2. So this is automatically going to go into this right here. We have a 1/2, and then this is going to be inverse tangent, and we're still going to put it's got to be the kx inside, so this is going to be 2x. So we have 1/2 inverse tan of 2x plus c. So this one we just used directly the formulas that we talked about at the beginning of this section.